Welcome to today's Explainer. I am so excited to unpack this one with you. Today, we're diving into a truly fascinating article from the SANS Institute, written by SANS fellow Steven Sims. We're going to explore the rapidly evolving role of artificial intelligence in offensive security. What happens when AI meets vulnerability testing? What does it actually get right? And maybe more importantly, why is human expertise literally more critical now than ever before? Let's get into it. So right off the bat, here is the central question we have to ask. Is AI creating more security signal, or is it just creating more noise? This is absolutely the crux of the issue in the cybersecurity industry right now. There's this massive industry-wide frustration building up because thanks to AI, we can generate these vulnerability-looking outputs faster than ever before. It's creating massive queues of reports. But the big problem we're unpacking today is that an incredibly fast, highly polished report, well, it doesn't always equal a real threat. Let's see why that is. All right, let's jump right into section 1, the AI security paradox. There is a really stark contrast at play here. It's a classic double-edged sword. On one hand, look, AI is undeniably fantastic at mechanical speed. It can read through huge code bases in seconds, summarize attack surfaces, instantly explain some unfamiliar API to you, and even draft testing scripts. It is a massive mechanical advantage, for sure. But because it moves so incredibly fast, it produces this historic surge of low-quality output. It spits out stuff that looks exactly like a vulnerability, but honestly often isn't. So the sheer speed of these AI tools is actually creating a crushing triage burden for security teams that, let's be real, are already totally overloaded with scanner outputs and compliance alerts. And this isn't just some theoretical debate, right? This has real-world impact right now. We are seeing bug bounty programs and software maintainers getting completely overwhelmed by what the industry is calling AI slop. It's gotten so bad that Bugcrowd actually had to step in and make public policy changes to address it. They were just getting flooded with these reports that looked perfectly polished. They sounded super professional, used all the right templated language, but they completely lacked meaningful human validation. It just created this massive bottleneck and completely failed to provide any useful security signal. Which brings us nicely to section 2. Output is not evidence. We really need to understand the difference here. I absolutely love this quote from Steven Sims in the SANS article. He writes, "A finding should answer basic questions clearly. Without that, the report may be interesting, but it is not ready to drive engineering action." That just brilliantly illustrates the reality on the ground. You can have this beautifully generated report, slap a high-severity rating on it, and include a plausible-looking proof of concept. But polished text does not equal a validated bug. If it doesn't actually prove the bug exists in the deployed environment, well, it's just a theory. So let's definitively separate what the AI gives you from what the human has to provide. Think of it this way. An AI gives you a lead. It might spot user input near a database query and confidently guess, oh, that's SQL injection, or it sees a URL fetch and suggests an SSRF. It's pointing out patterns, but it totally lacks contextual awareness. A validated finding, on the other hand, is where a human steps in. The human proves that the attacker-controlled input actually reaches that dangerous operation. A finding is reproducible, it explains the exact reachability, and it proves the impact in the actual deployed environment. An AI lead simply cannot guarantee that. So the crucial point here is avoiding what Sims calls the looks vulnerable trap. It is so dangerous to confuse a suspicious pattern with a validated vulnerability. An AI model might eagerly point out a dangerous API in a code path and confidently assign it a CVSS score of 9.8. But the AI is frequently blind to the crucial mitigating context. It doesn't know if that path is internal only. It doesn't know if the application sanitizes or normalizes the payload before it even reaches the dangerous operation. The AI generates the hypothesis. It's up to us humans to actually find the truth. And that perfectly tees up our next point. Let's look at section 3, the risk of rust. The SANS article issues a really stark warning here about what they call rust. We're talking about a very real brain drain in cybersecurity. Think about it. The best testers spent years manually tracing requests, reverse engineering binaries, debugging crashes, all to build this deep technical memory. But when you let AI instantly explain every single error message or write the first draft of every script, testers stop building their own mental models. They stop understanding parsers, allocators, identity boundaries. They literally lose their pattern recognition. And that leads to this critical warning. We absolutely cannot mistake fluency for competence. Don't get me wrong, AI orchestration is an incredible improvement for scaling known testing techniques. But knowing how to prompt a large language model, that is no substitute for the hard-earned judgment you need to reason through complex memory corruption or some twisted business logic. If practitioners stop exercising those mental muscles, they lose the exact skills that made them effective in the first place. Okay, so how do we fix this? Section 4, the validation checklist. If you are working in offensive security, this is essentially your new roadmap for separating the noise from the truth. Before an AI lead ever becomes a reported finding, a human being has to answer these questions. What specific behavior was actually observed? What exact security boundary was crossed? What are the exact reproduction steps? What is the demonstrated impact? And hey, is it even reachable in deployment? Rapidly running through this human-driven checklist prevents underreporting, but just as importantly, it prevents the really embarrassing over-reporting of exaggerated impacts. Like calling a reflected input cross-site scripting before you've even proven the script executes. And this really illustrates how teams should actually be balancing their workflow. AI is a massive force multiplier, right? Its role is to handle the mechanical heavy lifting, produce the candidates, suggest the test ideas, speed up your reproduction. But the human's role? The human steps in at the critical moment to review the evidence, verify that claim against reality, and truly understand the business risk. You use the AI to generate the leads, but taking it from a lead to a finding, that absolutely requires human-backed evidence. Which brings us to our final point. Section 5, the standard. Prove it. Because despite all these wild advancements in machine learning, the unyielding benchmark of the industry remains exactly the same. When it comes to high-impact findings, human validation isn't just some administrative checkbox. It is deeply technical. Humans have to prove authorization flaws involving super complex object relationships. We have to reason through memory corruption mitigations, figure out API tenant interactions, and untangle dense cloud identity trust policies. In fact, Tenable recently flagged this exact issue. They noted a growing AI exposure gap because automated systems completely miss these critical contextual combinations. An AI just can't contextualize a cloud trust policy inside your specific business logic. Only a human can do that. So the ultimate takeaway from the SANS Institute article is incredibly clear. The standard has not changed. Prove it. In offensive security, you simply cannot rely on a confident guess from a machine, especially when that result is going to affect engineering priorities or customer trust. You still have to prove the bug exists. You have to prove the attacker can reach it. And you have to prove the business risk. AI doesn't lower this standard. Honestly, if anything, it raises the importance of enforcing it. I want to leave you with a thought to chew on. In a future that is going to be utterly dominated by automated AI output, will you be drowning in the noise of 1,000 false alarms? Or will you be using your hard-earned technical judgment to prove what actually matters? Combining automation with undeniable deep expertise is exactly what's going to separate the best from the rest. Keep your mental model sharp, and as always, keep learning.